Good afternoon. Today we're going to talk about cross simplification when we're multiplying fractions. It's very important that you practice cross simplification, and it can be a little bit confusing at first, but it actually makes your life a whole lot easier. In the last video, we looked at an example of multiplying fractions where it was 1/4 times 2/5. When we looked at this, we just multiplied straight across because that's the process for multiplying fractions. We did 1 times 2, which is 2, and we did 4 times 5, which is 20. We then realized that 2 and 20 are both even numbers, so we can at least pull out a 2 from the problem. So we divided the top and the bottom by 2, which was our simplification or reducing step, regardless of which you called it growing up. So 2 divided by 2 is 1, 20 divided by 2 is 10, so it's 1/10 as your final answer. Now, from here, what if we looked at this again? So 1/4 times 2/5. Sure, we're going to get the same answer of 2 over 20 if we do it the normal way. But what if we could skip this division step, this reducing step, the simplifying step, and do it while we multiply or before we even multiply, making the multiplication process even easier as well? Well, what that means is, one, you have to look at your diagonals. So by the diagonals, I mean the numbers that are across from each other. So you'll look at the 2 and the 4, and then you'll also look at the 1 and the 5. So when you do that, when you're looking at those, do 1 and 5 have any factors in common? Well, they have 1 in common, so that's not really useful. But does 2 and 4 have anything in common? And if you have to write it off to the side, you can. But really, cross simplification is for those of you who have your multiplication facts memorized, so it's a little bit easier. Yes, 2 and 4 both have a 2 in common. So you'll take the 2 out. 2 divided by 2 is 1. 4 divided by 2 is 2. So then you have two new fractions. You have 1/2 times 1/5. 1 times 1 is, you guessed it, you got it, you guessed it. Trying to blend those together. Don't understand why, but that's what I did. So 1 times 1 is 1, and 2 times 5 is 10. So 1/10. These two answers are the same, so the process works. I know this is just one example, but trust me, it works. I didn't want to believe it either when I first did it a long time ago. So let's go look at another example that might prove it even further. We have 3/4 times, let's do 8/9. Now, in this case, when you're looking at our diagonals, I already know because I set it up that they have two numbers in common. One on the left and right, bottom right diagonal, and the one on the bottom left and upper right diagonal. So here you go. What do 3 and 9 have in common? Well, they have 3 in common, so we'll take out a 3. 3 divided by 3 is 1. 9 divided by 3 is 3. Now let's do the same with the 4 and the 8. 4 and 8 both have 4 in their factors, so 4 divided by 4 is 1. And 8 divided by 4 is 2. So 1 times 2, because we're doing regular multiplication of fractions now, is 2. And 1 times 3 is 3, and it simplifies to 2/3. That also saved you from having to deal with bigger numbers that are harder to break down. Now I know some of you still want proof that this actually still works, so I'll show you real quick. It'll be easy. We'll rewrite the problem, 3/4 times 8 over 9. Just be ready for a lot of simplification. 3 times 8 is 24. 4 times 9 is 36. Now, some of you may know they're both even. We can take a 2 out. But why not take something bigger out if something bigger goes into it? So let's pull a 12 out. We'll divide by 12 on the top and 12 on the bottom. 24 divided by 12 is 2, and 36 divided by 12 is 3, so you get 2/3 again. So again, here we have an example of where cross simplification saved us a lot of time and kept us from having to deal with big nasty numbers like 12 if you didn't know that 12 goes into both of those, because then you would have to divide by 2 or divide by 4 or divide by some other number that you know goes into both of them. And that will be how we cross simplify. It will work on all the multiplication problems of fractions where you can look at the diagonals like we did here. And if you have any questions, drop them in the comments. Thank you for watching, and stay tuned for more helpful math videos.